Hello and welcome again to RC Model Reviews, and today I'm looking at the Skyzone RC 700D 7-inch Diversity DVR monitor. And this is the attractive box in which it comes, unboxed. Right, now this is the unit itself. As you can see, it's an LCD screen. Now, I did review a previous LCD screen. I should point out, of course, as I always do, the disclosure that this was provided by Foxtech FPV for review purposes. And so you'll recall that they actually provided this one earlier. This is their non-diversity DVR 7-inch LCD monitor. I've reviewed it before. I'll put a link to that review in the description of this video. But that is a really nice unit. I do like it. It works really well in bright sunlight, has the non-glare screen, and the DVR is, satisfactory. So, it's, been my go-to LCD when I want to take an LCD to the field and show people what this FPV thing's all about. But now we have this one, and this differs in a number of ways. First of all, there are two SMA antenna jacks. It's got diversity, so it has a diversity receiver, and it has two little LEDs down here to show you which receiver or which antenna is actually active at any given time. It also has a range of little buttons here, as you can see, and it has some dip switches. Now, this is one thing I'm not too chuffed about. On the old one, on the other one they sent me, you can change your band and your channel with these little soft switches here, little clicky buttons, right? So it's pretty easy to step through and find a channel that's got something on it. If you're at a busy field and several people are flying FPV, then the old one is really handy. You can just whiz around, find a channel with something on it and show it to people. It's great. This one, you're going to have to get your little screwdriver out and dick around with the little switches. Not so good. So this is more of a screen you're going to use for your own purposes, not for showing other people what else is happening in the air. You're going to set it up to work with your video transmitter, and you're not going to change it very often. So with that in mind, the dip switch is not too much of a problem, I suppose. Other things to note: it has a standard mounting screw for a tripod. So the standard camera mounting screw there, I forget what it is, standard size. That's great because it means you can just stick it on a tripod. And in fact, I had it stuck on a little tripod I got with my Mobius, which is really good. So it's a little short, but it keeps it upright. We've also got a number of things on the side here. We've got some AV in, so you can use it as a regular monitor with a receiver, maybe a 1.2 gig receiver or something, who knows. AV out, so if you want to, you can use this as your video receiver. Stick it on a little tripod, put your aerials on it, and then plug this from here into your base type goggles, which may not have a receiver in them, or whatever. So it enables you to take the video out. Now, has USB? What do you use that for? Maybe if you're too cheap to buy a card reader, you can leave the card in there and use the USB to read the contents. I haven't tried it, but yeah, you can't charge it through the USB because, look, it has a place for a battery. Look, take this cover off the back, you can stick a battery in it. Now, the old one, the previous one, no room for a battery. You can't put a battery in this. It doesn't have a mounting screw either. So with this one, you have to use external power at all times. This one has room for a battery, and even tells you the dimensions of the battery you should use. And it says 2S, but I will tell you now and show you in a moment, do not use a 2S battery with this LCD screen, and I'll show you why later. But suffice to say, take my word for it. And it's a shame because it's actually quite a long, shallow compartment. So it's best suited to a 2S battery. The more cells you have, the thicker the battery tends to be. So it would take quite a decent sized 2-cell battery, but if you use a 2-cell battery, you will not get the expected operation out of it. It will actually shut down long before the battery is anywhere near exhausted. So that's kind of a waste of battery capacity. Some holes in the back. One's got a speaker on it, one's just for ventilation. And what else we got on the other side here? We've got some power options over here. Here we go. There's some kind of little square connector there, which will take 12 volts. There is a micro barrel jack, which is handy because they give you the lead to go with it. See, little micro barrel jack. You can plug that into a JST battery and power it externally from any size battery you like, from 2 cells through to 6 cells. And yeah, there's a JST, of course, inside for the battery. And that pretty much sums up what you get in terms of the box, except, of course, there are other bits that come with it. You do get that power lead, as I suggested, as I showed you before, and you get a couple of virtually useless 5.8 linearly polarized antennas. Anyone who uses these antennas on 5.8 gigs needs to kick up the backside because they're pretty useless, honestly. Now, you also get this. See, this is the shade hood. I mean, these are quite useful. One came with the other screen. It was a sort of semi-fabric one, I think. This is all plastic. And see that? Non-glare finish, but it's black. I suppose it has to be black if you want to have good anti-glare properties. Now, opening it up was a bit of a nightmare, actually, because it's got little catches on the side, which really do catch. So actually getting the damn thing open requires you to dig your fingernails in and pull the sides out. It's really not. There we go. That side's open. That side, come on, open up. It is, there we go, finally got it open. Ka-ping, and it springs open like that. There you go. So there's your shade hood. Little tongues on here, engage in little holes on there and on the top. So once it's clipped on, it's fairly sturdy. But see this, can you see? There's reflection in there. Now, this side is nice and matte, no glare. This side is shiny. Reality, this side should be matte. And who gives a damn about what this side looks like? So they could have, you know, they seem to have got a bit backwards. I would have loved to have seen the inside to be a non-glare surface and the outside, well, I don't really give a damn. But they got it backwards. Okay, probably not going to be a big thing for you, but just a, you know, oh, it's a shame, just a shame. Never mind. So there we go. I think what I'll do now is we'll plug it in and just have a look and see how it works. Okay, I've plugged in the screen to my benchtop power supply, 8.4 volts. That is the full voltage, or the maximum voltage of a 2-cell LiPo. And as you can see, the screen's working. It's got snow, so it says no signal, so there's no blue screen problems with this particular setup. It's drawing 1 1/4 amps roughly, which is quite a bit, but we do have a very bright backlight on that LCD, so it can be seen in the direct sunlight. So yeah, you would expect that power has to come from somewhere, and it's coming from our battery. Now, one thing to notice here is that the screen voltage here, the voltage on the screen, it actually says 6.9 volts. 6.9. I'm going to get my calculator and calculate how much that's wrong. So it's 8.4 minus 6.9 equals 1.5 volts low. This is reading 1.5 volts low on the screen. I'll just try and zoom into that so you can see that I'm not telling lies. Ooh, can we see that? It's going to focus. Yeah, 6.9 volts down there, but over here on the fluke meter it says 8.38, roughly 8.4 volts. So yeah, I'm not telling porkies. It's reading 1.5 volts low, and that's not good, because the last LCD did the same thing. But there we go, it's all plugged in, it's all running. But I want to show you something. Currently, we've got 8.4 volts. I'm going to wind the voltage down. Remember, this is designed to run on a 2-cell pack. Let's wind the voltage down and see what happens. So we're going down to 8 volts, still working fine. 7.7, 7.6, 7.5, oh, 7.4 volts. It stopped working, it's rebooted. Here we go again, it's just, oh, rebooted again. So at 7.4 volts roughly, it decides to stop working. So as you can see, when I go down, let's just do that again, just to make sure it wasn't some strange quirk, something that went strangely wrong. Now we're going down to 7.6, 7.5, 7.40, 7, there we go, 7.4 volts roughly. It goes into a reboot loop. It goes off and on, and it reboots. So I'll just disconnect it so we don't have any problems. So that means that if your 2-cell LiPo falls down to 7.4 volts, which is actually 3.7 volts a cell, you've still got heaps of power left in that LiPo, but the screen stops working. So what you don't really want to use a 2-cell battery with the screen, because you'll never get anywhere near the rated capacity out of it. So you have to use at least a 3-cell battery, and that battery compartment is too thin for virtually every 3-cell battery I've tried. But let's take a look at the menu functions now. It's got a menu key here. Let me press that. Bing, bing. We have menus. Simple as that. There's loop record. If you want to record your video so that if you've got a small card, you just want the last so many minutes of your flight or your day's flying, then you can put the loop record on, and it probably gives you a choice of options. Let's have a look. No, it's just on or off. Okay, so we're just going to leave it off. We don't want to. We just want to record until the card's full and then have it stop. Let's move down. We've got a date stamp. That's just on or off if you want the date stamp shown on the video recording. Memory info. That tells us, for example, in this case, the free space on my card is 6209 megabytes, and there's a total of 7572 megabytes, because there is some memory built into the LCD display itself, into the DVR function. So yeah, that's something I'll show you in a minute when we take the covers off and have a look. So let's have a look. Let's go down further. Format. You can format the SD card that's in there. You can choose your language. There's a number to choose from. Date and time. You can set the date and time, and that's remembered because it has a battery on board that remembers the time and date. You don't have to reset it every time you power it up. That's very good. I like that. Default. That just returns everything to its defaults. There's beep. Now if you turn that on, I'm going to show you. This is terrible. I don't know why you'd ever have this on, because now, do you listen to that? That is awful. Why would anyone have that on there? Even a beep's got to be better than that. So turn that off. We don't want that. Now next thing, TV standard. And of course it gives you a choice of PAL or NTSC, because you might be using either. It would have been nice if it automatically selected the correct TV standard according to the signals that were coming in, but I guess you have to actually make the choice. I mainly fly PAL, but I know at the field where I fly, several people fly NTSC. So if I wanted to watch their videos, I have to go through the menu and select the right video standard and then change the channel, little dip switches down here. So yeah, it's not as convenient as I say for watching other people's transmissions. It's mainly just for setting up on your own. So there we go back to there. Now we have battery type, and it says in the instructions, and I must say it does come with instructions, not particularly elaborate instructions or comprehensive, but it does have them. And it says in there that this will take 2 to 6 cell battery feed. That's fine. The inbuilt battery compartment is designed to take a 2-cell battery. And as I say, 2-cell battery, forget it. So when you go to battery type, you can select 2-cell, 3-cell, 4-cell, 5-cell, 6-cell, or you can ignore the horrible low battery warning that comes up. Now my advice to you is just set it to ignore. Just set the damn thing to ignore, and then you won't be annoyed by that battery warning that comes up way too soon because of the incorrect battery readings you're getting. Anyway, so I'll just leave it on 2-cell for the moment. Then we have LCD brightness. It has a range of brightnesses. I've got it set all the way onto level 1, on level 5, which is the brightest one. That explains why it draws 1 1/4 amps, because it really is, it's very, very bright. That's brilliant for outdoor use. So leave it at that. And then there's another function here, LCD full screen. Now one thing you notice about this screen and the other one is that they have a 16:9 aspect ratio. That means 16 units across for 9 units vertically. And that is, you know, that's the HD TV standard. Every HD TV now is a 16:9 aspect ratio, well, apart from some of the really expensive ones. But the old standard, the standard that comes out of your board camera on your FPV model is 4:3. That means it's 4 units across and 3 units high. It's more square. It's a squarish aspect ratio. So by default, this will display everything in 16:9. So if you were to point your camera at a circle, it would come out as kind of an ellipse on here, an oval stretched sideways to fit the screen. Now, that can distort the image you're looking at. Personally, I don't mind it. I prefer to have the bigger picture, even if there's a little bit of distortion there. But if you want to have the 4:3 image, then you can select this, and you can turn off the full screen. And then when you go back to there, notice it's now a squarish aspect ratio. It just leaves the sides blank, whereas before it was actually stretching this whole image out to fill the screen. Yeah, I don't actually like that. So I'm going to go back into the menu and go back to that full screen option, and I'm going to say I want it on, thank you. And now when I go back, I get the full screen. That's great. That's just what I wanted. So those are the simple menu options. It's not going to confuse anyone. It's really straightforward. Also worth noting on the screen here, we have some information I didn't show you before. It says it's in PAL format because I set that. Has 90% there. I think that's 90% of my SD card is available. I've already got 2 recordings. It has the time and date, which I set down the bottom here, and it remembers those because we have the the onboard battery to remember that information. And then I'm not sure what's down here, 2:48, oh, no idea, maybe that's the amount of recording time available, probably is 2 hours and 48. One thing to remember, with standard definition recording, this isn't HD of course, standard def recording, you fit an awful lot on a card, and I've got an 8 gig card I think in there, so I can get 2 hours and 48 minutes of recording. Woohoo, that's a lot. Now let's talk a little bit more about the kind of battery you can fit in the back here. As I say, if you put a 2-cell in there, because it shuts down at 7.4 volts, you're only going to use a little over half of that battery's capacity. So although it's quite a big battery pack space, you could probably fit in there, probably a 2650 2-cell battery would probably fit in there. You're only going to be able to use about 1400 milliamps of that, which is crazy. So I thought, can I fit a 3-cell in there? Because the 3-cell, of course, will work. You know, you can deliver the whole capacity of the 3-cell into the LCD because it's not going to stop working when it gets down to 3.7 volts per cell. Because at 3.7 volts per cell, your LiPo will still have 11.2 volts in it, your 3-cell LiPo. So I tried a few packs, and the one that I found that almost fits is pretty close as this one. This is the Zippy Compact. The Zippy Compact 1500 Zippy Compact. That actually fits just fits. I've got 2 of these Zippy Compacts. One fits, one doesn't, because the bit that doesn't fit is at the end here. We see it bulges out slightly, just gets a bit round there. I've got one that bulges out quite a bit and one that doesn't bulge out much. This is the one that doesn't bulge out much. So it does actually fit. You can close the cover. So if you change this to a JST connector, then you can actually use an internal battery. But the problem is getting the battery cover off and on with this battery is a real pain in the backside. And there's no switch. So as soon as you plug your battery in, the LCD's running. And so to turn it off, you've got to take the back cover off and unplug it. To turn it back on again, you've got to take the back cover off and plug it in. It's just, please, Skyzone, if you're listening, put a little, a 20-cent slide switch on here somewhere, so you can have an actual hard off-on switch that you can use, so you can leave the battery in there and turn it off and on as you choose throughout the day, okay? But now I think it's time that we have a look at the insides of this screen, see how well it's built, and also I'm going to try and explain a little bit about these erroneous battery readings. Getting the back off this thing's pretty easy. There's 6 screws, the back just comes off, and we can see inside, and it looks like a very well laid out, nicely designed, nice quality of manufacture. All the components are very well soldered. The thing that surprised me a lot was this area here. Now this is the power supply area. Basically what happens is here's our power jack that goes off to our internal battery, and here are our little connectors, the barrel connector and the other connector on the side that'll take external power input. They go through here into this section, and look at all these little inductors here. Each one of these is part of a switched mode regulator that is designed to convert from the 2 to 6 cell input down to the very tiny voltages that these chips use. Now, we're talking about 5 volts, 3.3 volts, 2.7 volts, 2.1 volts, maybe 1.5 volts. There's a whole lot of different voltages required to run these chips. So this section here is responsible for creating all those voltages, regulating them, and it's a major part of the whole thing actually. Down here we've got our two 32-channel 5.8 gigahertz receiver modules, because this is upside down. Over here, I think this might be the diversity switching circuitry here. We've got a speaker. Unfortunately, it's hardwired in. I couldn't unplug it, so this is just hanging off the wire there. Over here, we've got our AV in, AV out, and our SD card. So yeah, it's all laid out pretty well. But what I want to show you is this bit over here, because this is where our power comes in, and this is why I believe our battery reading on the LCD is so very, very wrong. All right, so here's our 2 external power sources, the little connector there and the barrel connector there. You notice these are just connected in parallel through this piece of copper here, but you notice that the power comes in here, the voltage comes in, and then there's a diode here. It has to go through a diode before it can continue on through the circuit. Now this diode is there solely to stop you from, well, one of the reasons perhaps is to stop you from connecting your battery up backwards, because if you connected your battery backwards, then you could blow the whole damn thing up. So this will only allow current to flow in one direction. So if you put the battery in backwards, no current will flow, no harm will be done. The voltage then goes off over here. Now this is a little FET switch. It's a little switch because we have a problem. We have a little problem here. Here's the wires off to our internal battery connection, and here are the wires to our external battery connection. If we just wire these in parallel, then you can imagine that perhaps we're using our LCD and the internal battery goes flat, and it may be a 2-cell battery or 3-cell battery. So we grab a 6-cell pack and we plug it in here, and what would happen? Well, you'd be putting 22 volts across an 11-volt battery, and the internal battery would explode. Simple as that. It would be like LiPos do if you put too much current into them and you overcharge them. This would just go boom and the magic smoke would come out. So we need some extra circuitry here to make sure that only one battery at a time is connected up to the rest of our circuitry. That's where this little switch comes in. It appears they've got a little FET switch here which detects to see which battery has the which source has the voltage applied, whether it's these 2 connectors or whether it's the internal battery, and then switches that accordingly into this piece over here, which is where the actual power supply circuitry goes on. But you'll notice there's another diode in here. So in effect, we end up with 2 diodes in series with the battery voltage that goes off to the supply. Now, I want to talk about barrier potential because it's very important. You don't get anything for free in the world. Time to go to the whiteboard. So here we are. This is a diode. Remember I mentioned diodes in that circuit that we looked at just a moment ago. A diode is a simple device. It's a bit like a reed valve. Now those of you who know about engines and various things know what a reed valve does. If you have a tube, let's have a tube here, and then you have a little area like this. I'll try and draw this the best I can. And if in here you have a little plate and you have a little valve on here, a little flexible membrane that can open and close, so it can go from that position to the open position, then when you blow air in here, it'll blow the valve open and the air can come out here. So it allows air or liquid to flow through a pipe. But when you reverse the flow, if you suddenly say, no, we don't want the flow going that way, wipe this out. If the flow tries to flow back this way, then this little flap here will slam closed over the hole and there'll be no flow out here. So it's a one-way valve. That's what a diode is. It's a one-way valve. That's why we have it in series with the power going into the LCD, so that if you turn your battery around the wrong way, it's not going to allow electricity to flow in and, going the wrong direction, destroy your expensive new LCD screen. So they put a diode in there to protect it. But there's no free lunches anywhere in the world. So As with a reed valve, when you put a reed valve in here, even when the air is allowed to flow through in the desired direction, so we have air flowing in here and air flowing out there, or water or whatever, and the little valve is open, a lot of drawing work going on here, like so, you lose some pressure. You lose some pressure and some flow because there's some obstruction in the way, so it takes a certain amount of, in fact, if you put a little pressure gauge on here, you would see that you'd have this much pressure here. If you put another pressure gauge on there, you'd see that the pressure was a little bit less because you're losing some because of the effect of that valve. And the same happens with our diode. Now, if we measure the voltage at this point, it will be some value. And if we measure it at that point after the diode, it'll be some value minus a little bit. So it'll be less. You'll have less voltage coming out of the diode than is on the input side. That's called the barrier potential, because inside the diode, it's almost like a little valve, and it takes a certain amount of voltage to open it before the current can flow through. And the amount of voltage required to open it is called the barrier potential. And on most of our diodes, most solid-state diodes these days, that is a number that is between I'm running out of ink in this pen, 0.6 volts to 0.7 volts, right? So until you actually have about 0.6 volts across the diode, no current will flow through it. It will be as if there was nothing there at all, no current will pass. So what happens is once the voltage reaches 0.6 volts, then current can flow. And the interesting thing is that no matter how much extra current you put through there, the voltage will stay pretty much the same. The barrier potential across the diode will stay pretty much the same. It'll only increase very slightly as you put a lot more current through. So it's a sort of a fixed amount. Now I noticed in the LCD screen that the voltage we had, the voltage difference between the battery voltage we were applying and the voltage displayed on the LCD was, let's take this out of the equation, I think I calculated it out there at 1.5 volts. It's not very good drawing, is it? I have to get some more pens for the whiteboard. 1.5 volts. Now I mentioned there were two diodes between the battery and the LCD screen. So if we divide that by 2, oh, sad pens. We divide 1.5 by 2, we get 0.75, which is very close to that 0.7 volt figure I was talking about. In fact, the other thing is there was a FET switch as well. Now FET switches, they don't generally cause much voltage drop, but you will get a little bit of voltage drop. So what I'm thinking is, the reason our LCD screen reads low is because we've got around about 1.2 to 1.4 volts drop across our two diodes, because they're in series, and the rest of the voltage, which is probably 0.3 to, or 0.1 to 0.3 volts, is across that FET. So there you go. Because they've put all this extra protection circuitry on the front of the power supply going into the LCD, the voltage that it reads is wrong, because all this extra circuitry is sucking up some of that valuable voltage. Probably that's also why on a 2-cell pack it starts having a hissy fit at 7.4 volts, because we've already lost 1.4 or 1.5 volts across all this extra protection circuitry. And so really the 7.4 volts at which it has a hissy fit is really a 6 volts by the time we get to the LCD circuitry itself. It's probably designed to operate from 6 volts upwards, but because we've lost 1.5 volts, it starts spitting the dummy at 7.4 volts. So that's why. So in a way, it's a good thing. It's a very good thing, because it means our LCD electronics are protected from silly people who might wire up a battery lead backwards or just do something stupid. On the other side, of course, it means that running a 2-cell pack in there is a complete waste of time, because you're not going to be able to use all the capacity. A lot of it's going to be wasted in all this, overcoming these barrier potentials for our diodes that are in the way. Simple as that. Didn't mean this to be a lecture on electronics theory, but there you go. I've thrown one in for free. So there we go. That's the Foxtech, or it's the Skyzone 7-inch monitor that Foxtech sent me for review. And in summary, well, let's look at the good points first. Diversity, that's a bonus. Put your helical on there, put your cloverleaf on there. You'll get a much better result than just having a single antenna. Contrast and brilliance, very good. Anti-glare screen, very good. No complaints at all there, no complaints whatsoever. It's got a built-in speaker, that's nice. It's got multiple power sources. It's got the two external jacks for putting up to a 6-cell LiPo on, and it's got the internal battery compartment, which will take a 2-cell pack, and a 3-cell if you push really hard and use the right battery. On the downside, What's wrong with it? Well, it's got some drawbacks, it's got some problems. First of all, as I said, that battery compartment's too small. It's just not thick enough. You can't put, I'd like to put it, it's almost big enough to put a 2200 3-cell in, and it would be really good, because if it was just another 8 millimeters deeper, you could put a 2200 3-cell in there and you could use it for over 2 hours, probably 2¼ hours of operation, instead of having to buy a really tiny skinny battery like this and try and squeeze it in with a shoehorn. Also, the battery protection circuitry they've got in there gets in the way of the voltage readout, makes the voltage readout and the low voltage warning on the batteries completely and utterly useless. It also means that the 2-cell pack you put in there, you'll only be able to draw about 50% of its capacity, and before the thing stops. And if you've got the battery alarm on, then it'll start showing low voltage within minutes of you actually turning it on. It just doesn't make sense. It's silly. That functionality is useless to you. These little dip switches here, I'm a fan of the ones on the old one where I can quickly flick through the channels and look at other people's transmissions while they're flying, because I like to watch what other people are doing. And if I can just go ping, ping, ping like this, it's great. If I have to get my screwdrivers out and start flicking these little switches, not so good. But I mean, that's okay if you're just using it for your own video transmissions, that's fine. It's not going to be a problem. Just would have been more versatile if they put soft buttons on there. Sorry, but oh, another positive I forgot was the built-in battery for the time and date backup. That's really good, so you don't have to keep resetting it after you change the battery or the battery goes flat. So there you go. Of course, that shade, the sunshade, that's the other thing that I'm not too chuffed about. It looks great on the outside, but on the inside, it's got all that glary stuff. I mean, yeah, just give the same finish on that side as is on this side, and everyone will be happy. Other than that, this fits, it works, great, can't grizzle too much. So there you go. That's my quick wrap up. Now, video is going to be the next thing to look at, because obviously this has not only the ability to receive and display video, but it has a built-in DVR. In my initial playing with the DVR, I'm quite happy with it. I'm quite impressed. It actually seems better than the DVR in there, but although it's probably the same thing. It may just be a little bit of an illusion, I'm not sure. So what I'm going to do is go out, I'm going to get plenty of video onto the SD card, and then I'll make a video up showing you what this looks like in sunlight and what the video recording that comes out of it looks like. I've got a little snippet to show you here, just a few seconds to show you here, give you an indication of how that works. And yeah, I'm happy with it, very happy with it indeed. In the meantime, if you've got questions and comments on this video, on the product, on the review, then please put them below the description of this video in the area carefully provided by YouTube for that purpose, and I'll do my best to answer them and address them. In the meantime, thank you for watching. I now have to get back to the slightly more cluttered bench.